In this example, we're going to describe the pattern that we see, write the next term, and then write a rule for the nth term. Let's look at part A. We've got a sequence here, -2, -5, -8, -11, ... meaning it goes on forever. To me, there's some link between these numbers. I think -2 minus 3 is -5, and -3 minus 3 is -8, and -8 minus 3 is -11. So if we describe it, it looks like you subtract 3 each time, or add -3. We're going to focus on this one when we write our formula. We want to think about what we're adding each time. It's not wrong to say you're subtracting 3 when you describe the pattern. I just want you to start thinking about it like this. We're going to write the next term. So -11 minus 3 is -14. That would be the next term in line. So we've described the pattern. We've written the next term. We've got to write a rule now for the nth term. If you want to use a formula for this, for an arithmetic sequence, that's where you're adding the same thing each time, and we are, we'll take a sub 1 plus d times n minus 1, and that will describe any arithmetic sequence that you have. All we need to do now is plug these values in. A sub 1 is the value of the first term, which is -2. D is -3. You could just do -3 if you wanted here. It doesn't really matter. And what I'm going to do is I'm going to clean this up by using the distributive property here. So we've got -2. -3 times n is -3n. -3 times -1 is +3. And if we move this -3n to the front and then do -2 plus 3, combine like terms, you've got yourself a +1 there. And that rule will accurately describe any position. You can double check yourself. Let's say you want the third term, which we know is -8. So that would be -3 times 3. N is 3 for the third term, which is -9. -9 plus 1 is -8. So at least for the third term, this formula accurately describes that. I'm just going to circle that in. That's probably something important. The next one, we've got 1, 16, 31, 46. This one, it's a little bit harder, it's a little bit trickier to figure out what we're adding by, and I know it right now, but that's because I think I've seen this one before. But if you're having trouble with this, all you need to do is take one term and subtract the previous term. So if we want to find D, that would be 16 minus 1, which is 15. We should also verify that you're adding 15 each time. If you're not adding the same thing each time, this is not arithmetic and we wouldn't be able to use this formula. But 16 plus 15 is 31. 31 plus 15 is 46, and so we are adding the same thing each time. What we want to do is describe this pattern though, so I would say add 15 each time. Pretty accurate description to get from term to term, or add 15 from the previous term to get the next one. And all we need to do now is find the next one here. Well, excuse me, not all we need to do. We need to do that and write the rule for the nth term. So we'll just do 46 plus 15, which in my book is going to be 61. That's a little bit of an elongated one. You don't have to do that if you don't want. Let's make it just regular style. And what we'll do now is we'll write that formula. So a sub 1 is 1 plus d, which is 15, times n minus 1. And then we'll clean this up a little bit by using the distributive property. So we've got 15n minus 15. We'll move that 15n to the front. And then 1 minus 15 is -14. You can double check. You can pick any one of these terms. And let's say we pick the fourth term. Well, n is 4 for the fourth term, so we've got 15 times 4, which is 60, and 60 minus 14 is 46. So at least for the fourth term, this formula accurately describes that position and value, and it will actually describe every single one in this wonderful arithmetic sequence.